Welcome to a lesson on proportionality and changing quantities. This is the first part of a two-part lesson. Previously, we had a video lesson that talked about clay for an art project that introduced the concept of proportionality in the context of trying to make a mixture of flour and water that would produce the same hardness of clay. We talked about quantities, and quantities were attributes of an object or a situation that we can imagine measuring. The quantities in this situation being observed were covariant, they were changing together. And there were three ways to reason proportionally. There was the scaling perspective we introduced, the constant multiple perspective, and also the constant ratio perspective. And these were introduced in that video. So let's continue on to the lesson itself. Your mom's favorite drink is Diet Coke with lemon juice. She creates the perfect mix by adding 3 teaspoons of lemon juice to the Diet Coke in a 12-ounce can. You decide to surprise Mom and make her favorite mix. You get distracted and put 5 teaspoons of lemon juice. So how many additional ounces of Diet Coke should you add to the mix so that the drink has the same taste and is not too lemony? So the very first thing we're going to do is let's define some variables for these quantities. So we're going to let L represent the number of teaspoons of lemon juice, and we're going to let D represent the number of ounces of Diet Coke. We do have already some information on this problem. We know that her perfect mix is 3 teaspoons of lemon juice to 12 ounces of Coke. So that's what's in a full can of Coke. And you had put 5 teaspoons of lemon juice, and so you want to make sure the mixture tastes correct. So what we're going to do is we're going to use the constant multiple perspective of proportionality. So in other words, what we're going to do is see 3 times what is 12. And when we think about this, 3 times 4 is 12. So that is going to be the constant multiple that relates the lemon juice, the teaspoons of lemon juice, to the ounces of Diet Coke. That means that if you have 5 teaspoons of lemon juice, you should put in 20 ounces of Diet Coke for the mixture to taste the same. So if we're looking at the change in D, okay, you have currently 12 ounces that were there, and you're trying to figure out how many additional ounces of Diet Coke you need to add to make the mixture taste the same. Well, 12 plus what is 20? That's 8. So if you add 8 additional ounces of Diet Coke should be added to the mix, that would produce a drink that still is the same taste and doesn't taste too lemony. So we concluded that 8 additional ounces of Diet Coke should be added to the mix. But let's look at this also another way. For example, we know that we wanted 3 teaspoons of lemon juice, but we accidentally put in 5 teaspoons of lemon juice. So that means we had 2 extra teaspoons of lemon juice. So what we could think about is, well, how much additional Coke do you need to add for the additional teaspoons of lemon juice? Well, we could take that using the constant multiple, multiply it by 4, and that would say that we need 8 additional ounces of Coke. So that's a second way to come to the same conclusion, that 8 additional ounces of Diet Coke should be added to the mix. Now when we're looking at the relationship of an equation that relates the number of teaspoons of lemon juice to the number of ounces of Diet Coke, it's interesting to observe that if you take the number of teaspoons of lemon juice and you multiply it by 4, you end up with the number of ounces of Diet Coke. And that's really looking at that constant multiple relationship. That means that we could actually just write this a little bit more simply as D is equal to 4L. So the constant multiple perspective of proportionality also helps us write equations. So that's a useful fact to know. Let's look at a different question as a follow-up. Suppose you had a 2-liter bottle of Diet Coke. How many teaspoons of lemon juice would you need to add to make a mix that tastes the same as your mom likes? Well, one of the things is this is being measured in liter, and your mom's recipe works in ounces. So let's first of all figure out how many ounces of cola are in a 2-liter bottle. To do that, let's just simply look at Google and type it in. 2 liters is how many ounces? And you find out that 2 liters is about 67.6 ounces. So we'll put that in the table. And so that's the number of ounces of Diet Coke, and we're going to want to work backwards to figure out how many teaspoons of lemon juice. So we know we have to have some number times 4 gives us 67.6. Well, let's think about this. If you want to reverse multiplication, you simply divide. So the reverse of multiplying by 4 is dividing by 4. And when we look at the table, you could see 12 divided by 4 is 3. Similarly, 20 divided by 4 is 5. 8 divided by 4 is 2. So that means if we take 67.6 and divide by 4, we're going to get the answer to how many teaspoons of lemon juice is needed. Also remember that dividing by a number is the same as multiplying by its reciprocal. So the reciprocal of 4 is 1/4. And so this will also come to the same conclusion that if you take 67.6 and multiply it by 1/4, or if you take 67.6 divided by 4, end up with 16.9. That's the number of teaspoons of lemon juice that's needed to produce a mixture that tastes as the same that your mom likes. Now realistically, you can't exactly put in 16.9 teaspoons of lemon juice, so you need approximately 17 teaspoons of lemon juice. And so this is how we use proportional reasoning to find the answer to how you keep a mixture preserved so that it has the same taste as before. Now looking at this, an equation, when you look at the relationship between a number of teaspoons and lemon juice and the ounces of Diet Coke is number of teaspoons of lemon juice is exactly 1/4 times D. And we can see it from the table as well. That's how the teaspoons of lemon juice and the ounces of Diet Coke relate through that constant multiple. And that concludes this example on proportional reasoning. I hope you found this helpful.